Yes. Hello everyone, this is D. Chinnagokari. In this video lecture I am going to explain particle nature of electromagnetic radiation and Planck quantum theory which explains the particle nature of electromagnetic radiation. Here Planck given the explanation for the black body radiation. So here before discussing the Planck quantum theory or this black body particle nature of electromagnetic radiation, let us discuss what are the failures in the wave theory of light. In previous videos I explained about wave theory of light. So wave theory of light we already know it can explain successfully reflection, refraction, diffraction, interference and also dispersion of light. But it is failed to explain about black body radiation and photoelectric effect and also hydrogen spectrum and also variation of heat capacity of solids with temperature. So these phenomena are not explained by the wave theory of light, but these phenomena we can explain by using the particle nature of electromagnetic radiation. So what is the particle nature of electromagnetic radiation? It says that light travels in the form of small invisible particles. That is the particle nature of electromagnetic radiation. So now let us discuss about variation of heat capacity of solids with temperature. So here when you heat a iron, so initially iron is in the dull red color when you are at starting stage, and when you increase the temperature, what happens, the dull red color slowly changes into thick red color, and then it changes into blue color, and then it changes into white color. So means the temperature increases, the frequency is also is increasing and the wavelength is decreasing, which means the only one object it is giving a different type of radiations. According to wave theory, the radiation is having continuous wave, which means it travels in a continuously in the form of wave. But here when you see in the iron, we are having different waves, different wavelengths we are getting. Means here light is not having a continuous manner, but it is having the discontinuous manner. And next coming to the black body radiation. So what is a black body radiation? Black body, first of all, what is a black body? Black body is nothing but a perfect absorber, a perfect emitter, which means it can absorb all type of electromagnetic radiations and it can emit the all type of electromagnetic radiations. That is called what? Black body. So here we can prepare a black body, almost a black body, by using a glass and coated inside with the platinum black. So that is almost act as a black body which can absorb the all type of electromagnetic radiations and all type of, it can release the all type of electromagnetic radiations, which means it can absorb all frequencies and it can emit the all type of frequencies. See here when you draw a graph, the intensity versus wavelength at a different constant temperature will get a graphs like this. So this is the temperature T1, this is temperature T1 and this is temperature T2. So here T2 is greater than T1. So here when you are heating a black body, initially it emits higher wavelength frequency radiation, and slowly the wavelength is decreases and the intensity is increases. Intensity is nothing but color. It is also called spatial radiancy. It is also called spatial radiancy. So here spatial radiancy increases, wavelength is decreasing, and on heating at a constant temperature, on heating slowly to at a constant temperature. So the slowly intensity increases and wavelength decreases after reaching a maximum intensity, then after it intensity decreases and it reaches to 0, which means here it emits the radiation. Next, when you increase the temperature, the same black body only, it gives the with again it gives from red color to dull red color to and again to a bright color intensity, means it give different type of frequencies with increase in intensity. So here when you increase the temperature, the maximum intensity shift towards the lower wavelength. The maximum intensity shift towards the lower wavelength, and then after reaching a maximum intensity again it reaches to 0. So here this wave theory is not given any explanation for this black body radiation, why the intensity is changing or why the wavelength is decreasing on hitting an object or any solid at different temperatures. Means according to wave theory, so the light is having wave nature and it travels in a single wave only, but here we are finding different waves with same object only at different temperatures. For this wave theory is not given any explanation, and this we can explain by using the Planck quantum theory, which supports the particle nature of electromagnetic radiation. So here what is Planck quantum theory? Now let us discuss. According to this Planck quantum theory of radiation, which supports the particle nature of electromagnetic radiation, so the black body emits its radiation in a not a continuous manner but discontinuous manner. So that so here black body emits radiation in discontinuous wave, means this is the discontinuous wave, but not in a continuous wave. So that a small discontinuous wave or this small particle is called photon or quantum. So this so the black body emits radiation in a discontinuous wave or discontinuous wave. This discontinuous waves or particles are called quantum. So here quantum is a small energy particle. It is a energy particle. The energy of the that small particle is directly proportional to its frequency. So here energy increases, frequencies also increases. So this discontinuous wave particles are called quantum. Waves or particles are called quantum. The energy, so it is the energy of the particle, and V is the frequency. So here to remove this proportionality, he gave one constant that is equal to h nu. So here h equal to Planck constant. Here h is the Planck constant. Its value 6.626 into 10 to the power of minus 34 joule second. So here E equal to h nu. So here energy emitted or the energy emitted by the black body is always integral multiple of h nu. It is always integral multiple of h nu, means E equal to n h nu. E equal to n h nu. Here n is the integral multiple or n is the number of particles or number of quantums. It is also called number of quantums. So here the energy emitted by this black body is always a integral multiple. Integral multiple means See, for example, one quantum, 2 quantum, 3 quantum, 4 quantum, like that only it emits the radiation, but not in 1.5, 2.5, 3.5, 7.21, like that it is not going to emit. Means it is one of the, we consider it as a one of the particle. We consider them as a particle, and the energy of the particle is given by the equation that is equal to E equal to h nu, or we already know E is directly proportional to nu. So here E is the energy of the particle, nu is the frequency, and E is equal to h nu. It is the energy of the one particle, and it is the energy emitted by this black body. It is always integral multiple of n. So here n is the number of that such type of particles, right. So here energy of 1 mole of photons, energy of 1 mole of photons, that is equal to E is equal to nh nu. So here n is the mole number or Avogadro number. So here I already said that here energy always emits in the integral multiples of, energy emits in always integral multiple of h nu, that is 1 h nu, 2 h nu, 3 h nu, and so on. Like that only energy emits according to the Planck quantum theory. Next we will discuss about photoelectric effect. This photoelectric effect phenomenon is also not explained by the wave nature of light. So now let us see what is the photoelectric effect. Photoelectric effect is nothing but when a light radiation falls on the a metal surface, some electrons are ejected from the surface of the metal. So that is called what? Photoelectric effect. This phenomenon is called photoelectric effect. So here how we can define a photoelectric effect? So the ejection or nothing but release, ejection of electrons from the metal surface, on supplying of or on irradiating with of suitable frequency of light. Ejection of electrons from the metal surface on supplying of suitable frequency of light, that is called what? Photoelectric effect. And the electrons which are ejected are called what? Photoelectrons. Here photo is nothing but light. So here the total phenomenon is called what? Photoelectric effect. And the electrons ejected here are called what? Photoelectrons. So here some metals are light sensitive like lithium, sodium, potassium, rubidium, cesium. When you allow to fall a light on that metal surface, they are going to eject their electrons, loosely bounded electrons. So that phenomenon is known as photoelectric effect, and here the electrons are photoelectrons. Here every time they are not going to give electrons, which means they require some minimum amount of energy only, then only they are going to eject the electrons. That minimum amount of energy is called what? Threshold energy. Threshold energy, or it is also called threshold frequency. Threshold energy is nothing but the minimum energy is required. The minimum frequency, which is required to eject the electron, is called threshold frequency, or threshold energy. See here, we are supplying, let us consider we are supplying threshold energy E. So it is converted E naught plus Ke. So here E naught, it is called threshold energy, E naught is called threshold energy. K is the kinetic energy, of the electron, and E is the energy of radiation, so what we are going to supply. So which means the energy what we are going to supply here, it is utilized in the two processes. One is as like threshold energy, one is as like kinetic energy of the electron, which means the energy, first it remove the electron from the metal surface, and remaining energy is converted as a kinetic energy of the electron. So here E equal to E naught plus Ke. So here when we observe this photoelectric effect, means when energy of the radiation is greater than the E naught only, in this case only we can observe the photoelectric effect. But when E is equal to E naught and when E is less than E naught, in these conditions we cannot observe any photoelectric effect, no photoelectric effect. So here we already know E equal to h nu from the Planck quantum theory. So in the place of h nu we can keep E equal to h nu. So here h is the Planck constant, nu is the frequency. So E equal to, or simply h nu is equal to h nu naught plus Ke. So here nu is equal to c by lambda, so hc by lambda is equal to hc by lambda naught plus Ke. Now what is the kinetic energy of the electron? So what is the kinetic energy? Kinetic energy of the electron, Ke is equal to half mv square, K is equal to half mv square. So how we can find the kinetic energy of that photoelectron? Simply Ke is equal to h nu minus h nu naught, or Ke is equal to hc by lambda minus hc by lambda naught. So now let us take the common hc. Now Ke is equal to hc by 1 by lambda minus 1 by lambda naught. By using this equation we can find the kinetic energy of that photoelectron. So this is about photoelectric effect. Simply ejection of electrons from the metal surface when you heat the, or when you pass some frequency, some light on the metal surface, that is called photoelectric effect. So the ejected electrons are called photoelectrons, and here every time we are not going to observe this phenomenon until unless the energy of this radiation is greater than the E naught. E naught here it is nothing but threshold energy, sometimes it is also called work function. So here energy of the radiation greater than the threshold energy or the work function only we can observe this photoelectric effect phenomenon. But when E equal to E naught or E is less than E naught, we cannot observe any photoelectric effect. And how to find this kinetic energy? Means the energy what we are going to supply is converted into two forms. One is some of the part of energy used as a threshold energy, and another part of the energy used as to eject the electron from the metal surface, right? So here how to find this kinetic energy? K is equal to half mv square. So here K is equal to h nu minus h nu naught, or hc by lambda minus hc by lambda naught. There K is equal to hc by lambda 1 by minus 1 by lambda naught. And let us discuss what are the So why this wave nature of the light cannot explain this photoelectric effect? Let us discuss. See here, we can observe the two type of processes here. We can change the intensity and versus kinetic energy. So here, whatever the intensity you use, intensity means the number of waves. Whatever the intensity you use, kinetic energy is not going to change. Kinetic energy is constant. There is no change in the kinetic energy of the photoelectron. But when you draw a graph between the intensity versus number of photoelectrons. So your intensity increases, number of photoelectrons are also increases. Intensity is directly proportional to number of photoelectrons. But intensity is means kinetic energy independent on the intensity. Whatever the intensity you use, there is no change in the kinetic energy of photoelectron. But here intensity increases, what happens? Number of photoelectrons are all increases. Number of photoelectrons are increases with increase in the intensity. With increase in intensity, number of photoelectrons increases, but in the increase in the intensity, there is no change in the kinetic energy. And another phenomenon here, frequency versus kinetic energy. So here frequency, C means initially we are using less frequency, then after we are using more frequency. So here frequency increases. What about here? The kinetic energy of electron increases. Frequency increases, kinetic energy of the electron is increases. But frequency, when you draw a graph between the frequency and number of photoelectrons. So here number of photoelectrons does not changes. Number of photoelectrons does not changes on increase in the frequency. Right? So here what we can understand from these graphs? See here, intensity means intensity is increasing. The brightness of this wave is increasing, means the light electromagnetic radiation is increasing. Then there is no change in kinetic energy. This photoelectron moves with a constant speed, but whereas number of photoelectrons are increases, means what is happening here? Intensity is increasing, means number of extra photons are coming here. Here less intensity means less number of photons, more intensity means more number of photons. Here less intensity means less number of photons, more intensity means more number of photons. See, we can understand here again. So it is the metal, so it is having different number of electrons here on this surface. So here first less intensity means only one photon is coming with that frequency more than that threshold frequency. It can eject the electron, means it is having so and so kinetic energy 1, and with same energy we are sending another photon, means here we can observe ejection of this electron also with the same kinetic energy 1, means and again we are sending one more photon with the same kinetic energy, the electron ejects, means here number of photons increases, means intensity also increases, but there is no change in kinetic energy. All are having same kinetic energy. But see here intensity increased, what happened, number of photoelectrons are increasing. So it tells that here light is not having continuous wave, it is having discontinuous nature, means it is having what, particle nature. Even though it is in intensity increasing, kinetic energy is not changing, means energy is not increased there. What increased there, number of photons are increased, number of light particles are increased, just that light particles are hitting the electrons, hitting this electron, and they are removing the electrons, just like when you, so let us consider a carom board, the red coin we can consider as a one intensity, light intensity, and the black and white coins we can consider as the electrons. So by using that red coin, we can, when we strike that red coin, what happens, it can remove that black and white coins. Simply here also number of that photons increases, electrons are also, ejected electrons are also increases, but they are going with the same speed, means there is no increase in the kinetic energy. This tells that light is not having a continuous nature, but it is having discontinuous nature. And when you are increase the frequency, whenever you are going to use the increase in frequency, for example here let us take one more diagram here. So let us consider here we are sending with frequency nu 1 and here new frequency nu 2. So here when you sending the frequency nu 1 is less than nu 2, which means when you are sending the frequency, it is having kinetic energy 1, and in the second case what I did here, frequency is increased. When I increase the frequency, so it again eject one electron, but here it is with Ke1, it is with Ke2, which means Ke1 is less than here Ke2, means frequency increases, kinetic energy is also increases, means first time we are using this frequency only, again next time we are removing this frequency 1 and again we are using frequency 2, then that time kinetic energy of the photoelectron is increased, but here also we are getting only one electron, here also we are getting only one electron, there is no change in the number of electrons, means frequency increases, number of photoelectrons increases, frequency increases, frequency increases, kinetic energy increases, first I said frequency increases, number of photoelectrons increases, that is wrong. So here frequency increases, kinetic energy increases, but number of photoelectrons does not changes. So here we are using with frequency nu 1, here we are using frequency nu 2. So here kinetic energy changed, but here also we are getting only one electron, here also we are getting only one electron, there is no increase in the number of electrons even though you are increasing the frequency, which means this frequency is nothing but it is only one photon. Here also we are having only one photon, but with different frequency. Here one bullet can fire, means when you, so let us, so now this is the light source, let us consider here we are firing the light, only one light, one electron, two lights, two photons, two electrons, three photons, three electrons. But in the second case, what I am doing, only one photon with frequency nu 1, in the second time again only one photon with frequency nu 2. So here also we are observing ejection of only one electron, here also we are observing ejection of only one electron, means light is having discontinuous particles, not a continuous wave, means light travels in the form of small invisible particles, right, according to this Planck quantum theory. So we can explain the photoelectric effect also by using this Planck quantum theory, and we cannot explain by using the wave theory of light. Okay, in the next videos I will explain some problems based on this photoelectric effect and also the black body radiation. Thank you.